weight of 25 plus or minus 25 marks. Question 2, a weight of plus or minus 7 marks. Question 3, it is plus or minus 17 marks. Question 4, plus or minus 25. Question 5, which will be plus or minus 17. Question 6, plus or minus 22 marks. Question 7, plus or minus 15 marks. Question 8, plus or minus 10 marks. And question 9, which will be plus or minus 12 marks. Now, if we are looking at all those questions, taking it from our question 1, what is that we expect in this question 1? In most cases, this is where we say our learners, let's take marks, because it's a question that must always welcome you as a candidate. We find it will be having what we call solve for X. Solve for X. And on our solve for X, of course, we can expect the 3 types of the solve for X, which one will be a solve for X which can be factorized. We have a solve for X which will definitely tell a learner that the answer must be correct to 2 decimal places, or depending on the examiner. Once it says correct to so many decimal places, it's simply telling the candidate that you cannot factorize that, but you must use the quadratic formula to can solve that. And the third part of it is where we are having an inequality. Those 3 questions, they're actually falling under the solve for X. And from that one, we are having our simultaneous equation. On our simultaneous equation, this is the question, of course, which will have a bit more marks, apart from the first 3, but still, we are still expected to solve on your simultaneous equation. And then you'll be given 2 equations, which, of course, one of the 2 equations, in most cases, it will be linear, and then the other one may be put as any curve. So your expectation is for us to make the linear one, make either y or x the subject of the formula. We shall make either y or x depending on which one is easier to can work with. We need not to take things that are a bit complicated. We make it easy for our life. Take either y if y can be easily be made the subject of the formula. And after that, then you substitute. Let's assume that you have y plus x equal to 5, and the other equation, maybe it may be x squared plus y squared minus 3, x, y equal to 4, something like that being given. 2 equations, you take the first equation, and this one is the second. You take the first equation, because it's linear, then you can make either y or x. For this kind of an equation, it's easy to make both of them, either x or y. One will say, let me make y equal to, therefore, I'm transposing the x to the other side, it becomes 5 minus x. So y is equal to 5 minus x. That comes from equation 1, then I can call it equation 1a. And then thereafter, the expectation will be to substitute this equation 1a into my equation 2 that I'm having there, which is, of course, the one of a curve. Then you do the substitution. But the key thing is, let us be able to make this y the subject, because once we have made y the subject of the formula, even in marking, that will be given a mark for that. From that, you'll be able to can substitute. Where you see the value of y in the given equation, you must then substitute 5 minus x. In other words, you will have something like x squared plus, in the place of the first y there, it's 5 minus x. I've put that in the place of y. That must be squared, minus 3. X in the place of y, again I'm having it there, it's 5 minus x. And that will be then be equated to a 4. Once we have done our substitution like that, once more, we get a mark for whatever that we have done, then we are now already having 2 marks by doing that. Once we have done that, then it's a matter of removing the brackets, and we remove the brackets. After removing the brackets, let me go through it, because that's where now most of our learners, of course, lose marks unnecessarily, because we lose concentration while working with that. So the easy way will be, when you are to expand that, have your 2 brackets, minus 3x into 5 minus x is equal to 4. Have your 2 brackets like that, because we make mistakes now in trying to square the first and square the last, and then that is definitely not giving the correct answer. But once we have the 2 brackets, then you are going to use your FOIL method in working it out, and then from there you will be working it out and then getting the values. At the end, you must get 2 values. The one is for x, the other one should be for y. You must have 2 values, because you are working those simultaneously. And you find that you are having 2 sets of x and y, but you solve both x and y. You may have 2 sets of those, and then that will be the answer to that one. And it carries a lot of marks. Sometimes it carries 7 marks as it is. Sometimes then as it can be 5 if we say it's not really being given marks. That is what. Then beyond that, in the same question 1, let's also expect the question that where you are given an equation, and then now you must change the subject of the formula. It will be given, it will be told that from whatever is given to you, I will just make an example, f equal to rx over p. It can be given like this, and then they say to you, make x the subject of the formula. All they are testing is how to manipulate this given equation and make x the subject of the formula. That is a very simple question, and in most cases it will be followed. After you have made x the subject of the formula, of course, they're just testing you that can you really do the cross multiplication on that and have it as rx equal to fp, and then divide that by r both sides, because now you are looking for your x, which is fp over r. Now x is now the subject of the formula. That's what they wanted. From this one, then they will give you some numbers in the where you are the value of f. They will tell f is how much. They will give you p equal to so much. They will give you r equal to so much. Then you will have to substitute this in the given equation just to conclude that type of equation. And beyond that, don't forget, we also have got on our question 1, we also have got the one of the binary number system. Let us not forget that we are also having the binaries, and it may be 2 marks on that one. Just to add the binaries. Just to add, you must be able to add, subtract, multiply, or divide. This is done in grade 10. This is done in grade 10 with binaries. Or out of this, the conversion, it's very key, converting from binary to decimal, or vice versa, from decimal to binary, or adding, being given and something like 101011, expected to add it to a 1101. They want you to add this kind. All that you must be able to. It's a very small marks that are input for this one. You won't go. There are 2 ways to edit like this. Just have to know. You put a 0, you carry a 1 and a 1. You still getting a 10. You carry a 1 over there, 1 and a 0. It's a 1 plus a 1. It's a 10, carrying that. And you just testing the addition to that. It's carrying a 1 and a 1. It's of course 1 and 0 plus that 1. You put a 1, you carry another 1 over there, and then a 1 and a 0, it's a 1, and then you bring down the 1. Then you have your answer. Either you add them like this, or you first convert from binaries to decimal using your table, both of them, and then add, and then after adding, then we can convert that back to the binary if they want their answer in binary. That is what to expect in question 1. Of course, like I'm saying, it's an easy question that will be welcoming all the candidates into the exam. Moving on to question 2. If you look on our question 2, which of course I said it's very few marks there, around 7, but it's talking to the nature of the roots. The nature of the roots. What we normally say is, let's understand this type of question. It is the nature of the roots, and even the question will always talk to, expect a candidate to to describe the nature of the roots. Will be expected to describe. And in most cases, they will say, determine the nature of the roots without actually solving. This is where now our learners are getting lost. If they say without solving, what do they mean? What do they mean if they say without solving? They expect you, they don't say don't work out the problem, but they say with using what we call the discriminant, which is b squared minus 4ac. In so doing, you're not solving. If you want to solve, if you are solving, that's where you are using, because when talking to the roots, in essence, we are talking to the x-intercepts. We're talking to the x-intercepts. And if you solve the x-intercepts, you will be able to can use the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. In doing this one, you are solving, but if you only concentrate on the number inside the radical sign, you are not solving, but you are now talking to the nature of these same roots that we would have found while we were solving them. So without solving means you must get the discriminant. And once we're talking to our discriminant, we actually saying the discriminant may be found in different ways, because whatever comes over there, it can be any number. Sometimes you may find that that number, that discriminant, it may be a number which is less than 0. And once we're talking of a number less than 0, of course, we're talking of a negative number. And once it's a negative number, then we must now know that negative number means we're talking now to the complex numbers. We're talking to the imaginary numbers. So once you are getting a negative on our discriminant, then it's telling that our roots are non-real. Non-real, or somebody will just use the word imaginary. That is, if the discriminant is less than 0, or our discriminant may be found to be 0. And once you get our discriminant to be 0, that means there, we say our roots there are equal. More than anything, they are equal. It simply means our parabola, because we are talking of a parabola here, is only touching the x-axis. It's not cutting. It's just touching the x-axis at one point. Then we say the roots are equal there, if the discriminant is equal to 0. That discriminant of us may be greater than 0. Of course, if it's not less than 0, it can be greater than 0. Now, once it's greater than 0, we said less than 0 is non-real. It's automatically telling us if it's greater than 0, then we are talking of the real. Those roots of us are real. Just by saying greater than, we mean they are real. But then, the number can be greater than 0, at the same time, that number being a perfect square. It can be a perfect square. And once it's a perfect square, it's a number greater than 0 being a perfect square. It's simply telling now the roots are, yes, being greater than 0, it was telling us about the real part. Now being a perfect square is telling us that these roots are real, at the same time they are rational. Rational. So greater than zero, being a perfect square, the roots would then be rational. Or it can still be greater than zero. It can still be greater than zero, the discriminant of us. But now, not being a perfect square. It's not a perfect square this time. And if it's not a perfect square, then we say the roots are irrational. They are still real, but this time irrational because it's not a perfect square. If it's a perfect square, they are still real, but now rational. And if we are looking at these ones, you realize we are talking equal to zero. The roots are there. They are real, even though they are equal. Greater than zero, they are there, also real. Therefore, we can combine these and talk of our discriminant being greater or equal to zero. And once it's greater or equal to zero, then we must know this time we're just talking of generally that our roots are real. That is what we to expect in our question 2, mainly we're talking to the nature of the roots, not carrying a lot of marks, of course, like I said, 7 marks when I started. And then the third question will be now talking to it will be talking to the exponents, it will be talking to the logarithms, it will also be talking to sets. Exponents, sets, as well as logarithms. So that question, let's understand that it carries, like we said, it carries plus or minus 17 marks. And it's just a matter of being able to simplify, work with, know the laws of exponents here, because we are having the laws that governs the exponents. Now, talking to the sets also, we must know how to work with the sets on that one. Talking to your sets, remember in technical mathematics that we include sets like the square root of minus 12. Let us be careful of that one, that if we are working this one out, that we must now bring in the idea of the complex numbers, which of course we must isolate this and have this as our square root of -1 multiplied by 12, something like that must come to our mind, and working it out to be able to separate and have that as square root of -1, which is to be multiplied by square root of 12, and now there it is, that square root of -1, which will be regarded as just an I times square root of 12. Of course, square root of 12 is 4 times 3, which means it's a 2, the square root of 3. So if you are working it out there, it will be 2 square root of 3 times I. There is that I. So in technical mathematics, we don't just look at it and say, the calculator, of course, will give you math error. We don't talk to that, but we work it out like isolating the -1 and then ultimately having I as our number under the sets. So let us be careful that it can come into that. And under logarithms, we must also be sure of the laws. We also have got the laws of logarithms, because logarithms and exponents, they work hand in glove. That's why they are even put under the same question. Remember that question will just carry plus or minus 17 marks. And let us be able to recall all the laws of exponent, know that the laws of logarithms. Let us not forget simple things like the log of 10, that will always give us a 1. That is always coming to our mind. If a question is given, let us be able to recall, or in anything Once we see log 10, then with log 10, we just bring it to a 1 and simplify whatever. Example can be, you may be given something like log of 16. I'm taking this from the paper that was set now in September. Log of 16 base 8 given to be added to log of 27. The base there is 9 and minus the log of 10. Now the base there is 1 over 6. Sorry. And out of that, now if almost everything has been added in this question, because the base is 8, the base is 9, is not the smallest base that we can think of, then we change the base here. The change of base is needed, having this as log of 16 divided by log of 8 plus log of 27 divided by log of 9. That we subtract over there. You can see now the base is 10, which is not written there. We can somehow use our law number 3 there, which will be 1 over 6 log of 10. You can put it like that. And then from there, you then have to change this one and have it as a log of, now the 16 can be written as Musa 2 to the power 4. And if you implement that, let me have it 2 to the power 4 over log of 8 can be 2 to the power 3, and then plus log of 20, log of 3 to the power 3 over log of 3 squared minus 1 over 6. Now log 10, like I talked of log 10, it's 1. In the place of log 10, we can somehow put 1. And now law number 3 can be applied here. We have it as 4 log 2 over 3 log 2. That 4 came there, the 3 came over there, plus the same thing here is 3 log 3 over this one, the 2 log 3 also, then minus over there is 1 over 6 times 1, it's just 1 over 6. Of course, the one log 2 cancel log 2, then we are having 4 over 3. This side, log 3 can cancel log 3, 3 over 2, then minus that. And then you are left with 4 over 3 plus 3 over 2 minus 1 over 6. Now we are just left with a fraction. Fractions that need just to be added together, you just choose the common denominator, which can be a 6. 3 into 6, 2 times that is 8. 2 into 6, then comes 3 times plus that is 9, 6 ones minus 1. And then from there you somehow add them, and once you add them there, 8 plus 9, 17 minus 1, 16, 16 over 6, which can be simplified further than that. But the key thing is to be able to can change the base, know what is your log 10, and then be able to write 16 as a power of 2, 8 as a power of that, you change that, and then you cancel, then it's just a matter of working mathematically. That's the basic thing around the logarithms that we shall be getting in our question 3. Let us not forget in that question 3 of us that we may also come across a straight question on complex, a straight question on complex numbers. Of course, with the complex numbers, let us know that under complex numbers, let us remember that we must be able to write these complex numbers in rectangular form. Rectangular form, which is A plus BI. That's the rectangular form. And be able to write whatever, whether we are given just a point